All right, so this is where we're at. Let's label things to make our life a little bit more organized. So this is our f1 plus f2. And this is our f2. And so our f1, thinking about tip to tail, should go tip to tail with f2 and line up with f1 plus f2 being the result. So starting here and ending up there. Okay, that's our f1 vector. So again, let's rephrase this as a vector subtraction. f1 plus f2 minus f2 should give us f1. Right? Just algebraically, that makes sense. I take away the f2, I'm left with f1. Okay? Vector subtraction, though, isn't really subtraction. It's kind of like an addition. So we're adding the opposite of f2. Okay? That's an important concept to understand. This leaves us with f1. So our process, just to kind of recap and do it again, is to find the components of these things, add them using components, then we have f1, and we have a nice 90-degree triangle to work with. So let's start with f1 plus f2, and we'll find its components. So the formula is magnitude, which is 2, times cos theta, whatever theta is. We'll find that out in a second, and then 2 sine theta. So our theta that we want to plug in right there is the angle between f1 plus f2 and the x-axis. So this little piece right here. That's what we want to sub in to the formula. So thinking about how we drew that, 260 degrees was the bearing. So 260 degrees took us starting at north, going all the way around to there. Yep, it's going to do that again. Okay, going all the way around to there. So same way as before, we're going to take 270, which would be from north all the way to west, and we're going to subtract the 260 piece, leaving us with that little sliver. So 270 minus 260, 10 degrees. So 10 degrees is that angle right in there. So we're subbing that into our formula. 2 cos 10, sine cos 10. So that gives us 2.0, pretty close. And 0.3. Okay, think about our signs. So we're going this way. That's the negative x direction. So let's add a negative to our x. And then from there, we're going down to get to our f1 plus f2. So that's the negative y direction. Add negative to both. Okay, now let's do the same for the f2 vector. Find its components. So magnitude is 0.3 cos theta and 0.3 sine theta. Theta is going to be what we put in right here. It's going to be this angle between f2 and the x-axis, right there. So what is that? Well, we did south 45 east. Okay, so 45 is this piece right here, which means that the other half between south and east, if this is 45, then this also has to be 45. 2 45s make a 90. perfect. So 45 and 45. Zero 0.2. And 0.2. What about their sign? Positive x direction. So again, think about the way that we're going here. So we're going this way, positive x direction, and then down, negative y direction. So, oops, it should be negative y direction and positive x direction. Like that. Yeah. Right. Then we go and find the opposite of f2. Because remember, we're adding the opposite of f2 to f1 plus f2. Opposite of f2 should be negative 0.2 and positive 0.2. Beauty. So now, if we take our little expression and we sub in the values for it that we have, so that is negative 2.0 and negative 0.3, and we're going to add them to negative 0.2 and 0.2, and this should give us f1 vectors components. So that is negative 2.2 for the x and negative 0.1 for the y. That is f1's components. I suppose we didn't really draw this on our diagram, which isn't really necessary. It's just kind of a conceptual. Do you understand how this is actually pictured? Right? We didn't need to redraw the opposite of f2, put it here, draw f1 again. If you want to, if that helps you, by all means, that's completely fine. But we can kind of skip that step, I think. Okay, so our f1, and just to get an idea of what this means, here's our f1 vector, approximately sized and directioned. And we have the horizontal piece, which is negative fairly significantly, right? So that's a negative x direction, followed by a tiny little negative y direction. So it should match up. It should make sense here. So something like that are the components for it. Something like that. Okay. So what are we doing? So let's label. So this is f1. This is our x direction. This is our y direction. So remember, we only need to find the bearing. We don't need the magnitude, it's already given, so we just need the direction. So we're going to find our bearing. And if I think about on this little diagram here, right, so I think about it based on the origin, which we can redraw it so it is, right? This would be my north, this is my east, this is my south, and that would be my west. And ultimately, if I want the bearing, I want to know the angle from here all the way to there, right? That is the bearing, starting at north, going clockwise. So in terms of my triangle, I can find this interior angle. This tiny little interior angle should be a small little angle. Then, if I want to know the remainder of this, what should I do? 270 minus that little bit should give me the rest of it. Okay, so we're going to need one quick little video to finish this off, and we'll finish off, and that's the end of the lesson for today.